Hey there, you're welcome to this week's Tech Tuesdays webinar on CDQ Custom Dashboard Utilizing IICS REST API. I'm Vrinda, your host for today's session, and we have with us Vivek Singh, Solution Architect, who will be presenting for today's session. Before we start this session, let's go through some housekeeping tips. The duration of the webinar is 1 hour. That includes a 15 minutes Q&A. You can post your queries in the Q&A box. Dial-in participants are muted for the entire session. The session is being recorded and will be available in the Informatica Support YouTube channel and the Success portal. You'll also be able to download the slide deck from the Success portal. Also, put in your feedbacks and suggestions in the post-webinar survey and let us know about your thoughts about the session and your suggestions about future topics. The Tech Tuesdays webinars are hosted within the Success portal, which is a Mac learning platform that offers free and unlimited learning to all registered users. This feature-rich platform was launched to help you learn and use Informatica products better. Here are a few important links that you can go over later that will help you in your product adoption journey. Over to you, Vivek. Thank you.
Thanks for the introduction. Hello everyone, this is Vivek. I'm working as a solution architect with Customer Success Technologies team, and I have Sachin Jain with me, who is a principal customer success technologist. Agenda of today's session is, first we will have a quick overview of the solution, then we will talk about why this solution is needed or what was the use case behind the solution. We will talk about design of the framework, its components, and all the steps involved. Then we will have a look at scope of the solution and all the technical aspects of it. We will also have a demo which shows what the end product is and how you can utilize this solution for your use cases. At the end of the session, we will open this forum for any questions you may have. Let's start with the overview. The solution which we are going to talk about in this session, we are calling it as a Cloud Data Quality Reporting Dashboard template. This is basically a framework which enables users to capture data quality metrics and dimensions by extracting profiling data from the profiling warehouse and showing the consolidated result in a third-party reporting tool. If you profile something in CDQ, the data which you can see on the profiling page, like null, not null, distinct, unique percentages, for each column is stored in a database called Profiling Warehouse Database. This database is not exposed directly to the users, but there are REST APIs which can be utilized to fetch data from the Profiling Warehouse Database. We will be utilizing the same APIs to read data from Profiling Warehouse, and using that data we will be building a report in third-party reporting tool, the PowerBI in this case. You can utilize any third-party reporting tool which is capable of reading CSV files to build such data quality dashboards. So this framework includes a Python script which will be calling these REST APIs to pull the data from the profiling warehouse, a sample Power BI report, and some sample CSV files which are used to build this sample Power BI report. So once you download the package, you can point the Power BI report, the sample Power BI report, to the sample data files, and report should be up and running. Later you can make the necessary modifications in the Python script to pull the data from your own IICS organization. What was the need of this framework? So when you profile something in cloud data quality, profiling is done on a specific data set. But many times business users want to have a holistic and a summarized view of all the data quality anomalies identified in the enterprise or in the department. In that case, default profiling result page will not be useful because it's showing profiling details or data anomalies only for a specific table and not the data anomalies across the enterprise or department. So to solve that issue, we can have a custom dashboard build which will be reading the profiling data from profiling warehouse, and it can show the consolidated result on a single screen. So the entire idea behind having this framework created is providing business users a single window where they can see data anomalies across the enterprise or department. Users can find all the data quality rules, their results, profiling results for each and every subject on a single window or on a single page. So this saves user time, enable them to have an accurate data quality monitoring system in place, and it also helps them to provide an immediate feedback on the data anomalies into the current and trending state of the data. So by having this solution, business users need not go to the profiling result page again and again to look for the data anomalies. Instead, they can simply open this custom report and monitor the data quality over the period of time, and can even drill down to see the profiling data and provide their feedback immediately. Now let's talk about the design of this solution or this framework. So on IICS platform for data quality, there are two microservices. One is a data quality and another one is data profiling. Now this data quality microservice is used to define your data quality business rules. So in this microservice, you can create all of your business rules. And data profiling microservice is basically used to create your profiling, right, on a particular data set. And you can even use the assets or the business rules which you have created in data quality microservices in the data profiling. So first you can create your rules in the data quality microservices, and then you go to the data profiling microservices, create your profiling on a particular data set, and you can attach the rules created, right, on the profile, and you can execute the profile. So that's how the structure on IICS platform is. Now, once you profile something, right, on IICS in data profiling, the result gets stored into a database called profiling a warehouse. And similarly, when you create a profile or when you create any rule, that gets stored in a database called repository service. On IICS, we call it as a FRS, Federated Repository Service. So both the information will get stored in certain kind of databases, right, for which users will not be having direct access. But these data is exposed to users in the form of REST APIs. So IICS provides some REST APIs. So one type of REST API is basically related to profiling, and another type of REST API is related to FRS, right? So we use those APIs to hit the profiling warehouse and FRS database to get the information, and that information will be returned in the form of JSON, and that JSON is parsed into the CSV format. So if you see on your screen, we have a Python script in place, and that Python script is going to call this 6 APIs. So there are 5 APIs related to the profiling, and there is one API related to the FRS. So we are calling all these APIs one by one, and then getting the response in the form of JSON, and then we are translating that JSON into the CSV, and we are generating 5 CSV files out of that. And on top of these 5 CSV files, we have built this custom reporting dashboard using Power BI. We will talk about each and every REST API which we have listed here in detail in next slide. But for now, this is just remember, this is how on a high level our solution is going to work. So now let's have a look on the scope of the solution. What is included in this solution and what is not, and what else you can do further, right? So before we go further in detail with the scope of the solution, right? Let's quickly have a look at the prerequisite. So the very first thing is, before you start using this solution, your data quality rules should already be created on your CDQ microservices. And this needs to be attached to the profile on CDP, and your profile needs to be executed, right? Unless you execute your profile, data will not be available in your profiling warehouse, and you will not be able to see anything on the custom reporting dashboard. And so it's necessary that your profile needs to be executed before using the solution. You need to have a user account, which we will be using the Python script, which should be able to hit the REST API, and it should be having access to all the CDQ rules and CDP profiles, right? So in CDQ microservices, you will be having all the rules. So it should be having access to all of the rules and all of the profiling. And then only you will be able to see all of the profiling results in your custom dashboard. So if a user is having access to only limited set of profiles or rules, he will be only able to extract only those information, and so your reporting dashboard may not show a holistic or a summarized view of data anomalies across the enterprise. So it's necessary that a user needs to have access to all the assets in the organization on IICS platform. And then you need to Python installed on your machine where you are going to execute this script, right? And that Python should have all of these libraries installed. So these are the default libraries, right, which comes with the Python installation. But these are listed in case if something is missing, you can cross check and you can install if something is missing. So once you are done with all of the prerequisite, right, then you can start using this solution, right? So in this solution, what is provided basically? So a Python script is provided, which is going to call the REST API, and it's going to capture the response in the CSV files. And then we are using those CSV files, those 5 CSV files, to build a reporting dashboard using a third-party reporting solution. So this is what is included in this particular framework: a Python script and a sample Power BI report. And you will also get sample CSV files, which is used to build this report. And then what is not included, but you can further enhance it, right? So in a real-time project, you might be interested in automating this Python script execution so that CSV files gets generated automatically on a regular interval, and your report should show the latest data always, right? So in that case, this Python script execution can be automated in various ways. So if you are running this script on a Linux machine, you can use cron job to schedule it. If you are running on Windows machine, you can use Windows task scheduler. Or if you are using CDI, then in CDI also you can automate the Python script execution using command task. So this particular portion we will discuss in detail in next slide on how on a sample, giving a sample how you can do this automation step. So this slide talks about all the REST APIs which we have used to build this solution. So the very first API is login API, right? So we are using this IICS API to log into your IICS platform and get a session ID. And that session ID will be used in all the successive APIs calls, right? And the session ID which you will be getting using this API, that is valid only for 30 minutes of inactivity. So if you have generated your session ID and if you're not doing anything, that session ID will be expired after 30 minutes. And if after generating the session ID, if you are doing something, then that will not expire, but it will keep it will be active, right? So the very first step is to log into IICS platform using this API and get the session ID. Now, before I move further, if you notice this POD region, right? This text is red highlighted here. Now, what does it mean? So basically, once you get your IICS credentials, right, from the Informatica sales team, your org is assigned to a particular pod region, right? So if you are based in US, you might be assigned to US pod region. If you are in Asia, you might be assigned to Asia pod region, and likewise. So based on your location, your org must be assigned to a pod region, and that region information needs to be passed to this API in order to connect, right? So from where you can get this pod region information? This information you can get from your IICS login URL, right? So I will show you from where you can get, but on the second API also, right? You can see I have highlighted pod in this green color, right? So what does this pod mean? So in each pod region, there could be multiple pods, right? So let's say in US pod region, there could be North America pod, there could be West side pod, right? So this pod is indicate that only. Now this pod is basically gets calculated during the runtime, so you don't need to worry about, but even you can get this information from the your IICS login URL itself, right? So I can show you both the things here. If you go to your IICS login URL, and if you notice here, so DM-US, right? So this US is nothing but your pod region, and this particular thing NA1, right? This is nothing but your pod. So inside US, I am assigned to, my org is assigned to NA1 pod here. So that's the information which we need to pass it to this API in order to work it. So you just need to provide this pod region information, and this pod will be automatically calculated during the runtime by the Python script, right? And then in rest of the APIs, we are passing the profiling ID and the column ID to get the details of a particular profile or particular column. So let's have a look at these APIs here. So there are 5 profiling APIs which we are calling. The very first API is to get the list of the profiles. So using this API, we will be getting all the profiling detail of all the profiles. So basically, we'll be getting the list of all the profiles for which the user is having access to in the organization. And once we get that profile list of profiles, then we will be passing the profiling ID to the second API, and then we will be getting the profiling information for each profile, like what are the profilable fields in a particular profile, what are the rules tagged, the sampling options, if any filter is enabled, who has created the profiling, and those information we will be getting using this API. Further, we will be passing the profiling ID and column ID, and we will be getting for each column what is the column profiling result. So whatever you can see on your profiling, right, this null percentages, not null percentages, all this information will be getting using this API for each column. And then for each column, we will also get the top and value frequency. Basically, in our solution, we are capturing top and value frequency only for the rule related column. We are not capturing for the remaining for the normal columns, because that's how we have built the solution, right? And then we have another API where we will be passing the profiling ID information, and we will be getting all the run stats, like when a profile was executed, what was the start time, end time, the memory taken, and the number of rows processed. So those information will be getting from this API. We also have a API called FRS API, right? Basically, this is the API to query the federated repository service to get some additional metadata information for the profile and for the rules, like who created the profile and which folder, which project a particular profile or a particular rule is created, to which dimension a rule belongs to. So those information we'll be getting from the FRS API. Now, what this Python script is doing exactly, right? So these are the steps listed here, which this Python script is doing. So the very first thing is this: when you start executing this Python script, it is going to check whether a folder exists on the machine or not, right? So this is a folder where it's going to generate a CSV file, and we need to provide path of this folder. So it is going to check whether in that particular path that folder exists or not. If it exists, then it will check if there are any existing CSV files in that folder. If there are CSV files, then it will be archived. And if the folder does not exist, then it will create the folder, and then it will start generating the CSV files in that folder. So once the folder is created, it's going to call these APIs one by one, and it's going to generate the CSV files in the folder. Now, if you notice here, there are two APIs, the login APIs and get the list of the profiling APIs. These are not generating any CSV files because these APIs are basically used for calling all rest of the successor APIs. So from the login API, we'll be just getting the session ID, and that will be passed to rest all the APIs, right? So the second API is basically to get the list of the profiling, and those after getting the list of the profile, we are passing that profiling ID to rest of the APIs, and those APIs are getting the detail from the profiling warehouse, and then we are capturing those information in all of these CSV files. Now, what these CSV files contain, right? So the very first CSV file, profile underscore metadata details. These capture detail of a particular profile, right? What are the columns in a particular profile? What are the rules tagged to a profile? Who created a particular profile? When it was created? So those metadata information will be available in this CSV file. The profiling rule output field will capture information related to data quality rule, right? What is the FRS ID of a particular rule, or what is the output field of a particular rule. So those information will be captured in this particular CSV file. Column underscore profiling underscore result.csv. This CSV file contain column profiling result for each and every column. So the null percentages, not null percentages, distinct, those information will be captured in this CSV file. We will also have top n value frequency, which will be available in this particular CSV file, and the profiling execution stats will be available in this file. And this particular profile underscore metadata detail is again the same file which we have already talked about in this particular step, but this particular API is only capturing some additional information, additional metadata information, and it's appending those additional metadata information in the existing file itself for each profile and rule. Once these APIs are called and CSV files are generated, there are few temporary files generated during the process. So those temporary files will get deleted by the Python script automatically at the end of the process. So on a high level, these are the steps this Python script is performing. So once the Python script execution is done and we get the CSV file, we are using those CSV files, those 5 CSV files, to build a reporting solution, right? So in Power BI, there is something called a model, right? And that's what you can see on the screen. So we have tried to link these CSV files using based on the primary and foreign key, right? We have tried to establish a relationship to create this model. Now, why this particular model is used, is created, basically in the Power BI report, if we want to do cross report filtering, right, or cross graph filtering. So let's say if I select filter on a particular profile, right, profile ID, all of the graphs in a particular worksheet should automatically get refreshed, and it should show detail only for a particular profile ID. So to enable that cross graph level filtering, we need to establish this kind of model, and that's why we have established this model basically. So this is nothing but for all the 5 CSV files based on the unique key combination. We have linked it manually and we have generated this data model in the Power BI, basically, which will be used for the cross filtering. And so let me quickly open the Power BI report itself and try to show you the data model here, right? So this is how the data model looks like. We have all the 5 tables here. 1, 2, 3, 4, 5, right? And then we also have a temporary table here. So this temporary table is basically temp underscore profile metadata detail table. This table is created on top of this particular data set, right? So this data set, temp data set, is nothing but it is referencing to this data set, but we have created this particular data set so that to get a certain kind of summarized data out of from this particular data set. So you don't need to worry about this particular data set. It's just referencing this data set only. And this is how the relationship is established. You can open this Power BI report and you can see the relationship from this package, and that's how it is created, right? So Let's go back here. Okay, so once this data model is created, you don't need to do anything in this data model because these are already created, right? Uh, uh, and then in this sample dashboard, there are two reporting. There in this particular in this report, there are two dashboards provided. The first dashboard is a DQ dashboard, and the second dashboard is DQ Asset Analytics. So let's jump into the Power BI here. So these are the two dashboards provided in this report. The DQ dashboard, this basically captures information like what are the uniqueness percentage, completeness, validity, accuracy percentages, right? So this is showing the aggregated percentage for the current execution, and similarly, these are the aggregated percentages for each dimension for last 9 executions. So these color bars basically shows each execution, like this was for previous execution, this was for previous -1, and so on, right? So for each execution, what was the uniqueness, aggregated uniqueness percentage, completeness percentage, validity, accuracy percent, that is aggregated percentage is shown here. And similarly, these two graphs basically shows the top 5 DQ rules, right, and bottom 5 DQ rules for each execution. So basically, these if you see, these are showing just once. That means this rule was tagged to a profile which was executed only once, and this particular rule is tagged to a profile which is executed 9 or 10 times, and because of that, it is showing for each and every execution. It's showing the aggregated percentages, right? And here left side you can see there are some filters provided. So these are the filters based on the project. So these are the project. If you expand in project, you will be able to see the folders, and inside that folder you will be able to see the name of the profile. So you can choose the filter, and these reports will get refreshed automatically. So let's say I want to apply filter on a particular profile. I can go and I can select a profile, and if you notice, these reports will automatically get refreshed here. Similarly, if I want to apply filter on a particular project instead of a profile, I can go and I can choose a project, and these reports will automatically get refreshed there. Now, if you notice, the second filter, which is our data set type filter, is also got a refresh, right? As soon as I have selected this particular project. So in this particular project, only Oracle sources were there on which the profiling was done, and that's why you are able to see only the Oracle source here. Now, if I remove the filter from here, you will see all of the data sets are listed here. So you can apply filter on data set also. So in delimited, you will be able to see the files, right, on which the profiling is done. So this is a CSV file, this is a text file. Similarly, in Oracle, you will be able to see the tables on which the profiling has been done. You can select any of these to filter out your report. So let's say I want to see only profiling result, only these data quality anomalies only on a product table. I can select that product table from here, and these reports will get refreshed. So you see, only uniqueness and completeness is showing. Rest all became blank because there was no validity or accuracy check done, or there was no rule applied on this particular table. These are the vanilla profiling is done, and that's why you are able to see only the uniqueness and completeness percentage. You can also drill down each and every graph here. So let's say I want to see data, the underlying data for this particular run. So right, so for this particular rule, I want to see the data for previous run -1, right? So I can select that, and I can right click on that, and I can go to the drill down. And if I go to the drill down, it is going to show me the underlying data. So it's going to show me this particular rule. This rule belongs to which dimension, it is tagged to which profiling, and this profile is which profile, which column, and this profile is under which project, which folder, and likewise, right? So that detailed information will be shown here. So similarly, you can drill down on anything. Let's say I want to drill down on validity for this particular thing. I can right click, I can go here, and I can just click on the drill down. It is going to show the drill down data for that. You can also click on any of these bars to filter out the entire report here. So let's say if I am clicking on this, the entire report got refreshed here. So this is basically the cross graph filtering, right, for which the data model we created in the Power BI. The second dashboard is basically, we are calling it as a DQ asset analytics here. So this dashboard shows the stats of all the objects created in the data quality profiling, right? So here you can see the total profiles created. Out of total profiles, how many are without rules, how many are having some sampling options enabled, how many are with some filters enabled. So those stats are shown here, and each user has created how many profiles. That distribution is shown here. Similarly, the rule distribution is shown here, how many clean rule are there, how many parser are there, how many rule specifications are there, and in that rule specification how many belongs to accuracy or validity, and so on. Similarly, each profile is executed how many times. That stat is shown here. So this particular profile is executed 21 times. Out of 21 times, 20 times it was executed in this particular folder, and one time it was executed in this particular folder. And this graph basically shows the profiling execution distribution over the period of time. So in this basically showing the year wise, right, by default. So that means in 2019 only one profile was executed. In 2021 total 10 profiles were executed. You can further drill down this to if you want to see it as the at a quarter level or month level. So you simply go here. If you click on this, it will be drilling it down to quarter level. Further you can drill it down to your month level, right? And then you can also drill it down to your date level. You can also drill down these reports also. So you simply right click on that, go to the drill through, and you click on this profile stats, and it is going to show you the drill down data for this particular report. Now, few reports like profiling stats and rule distribution, these graphs, it does not support drill down, and that's why this drill through option is given at the top. You simply press Control and click on this drill through, and it is going to redirect you to a different report here. And in this report, you can click on any of these tabs, and you can see the drill down data for that. So let's say if I want to have a look at what are the profiles on which any filter is enabled, I can click on this filter enabled, and I will be able to see only those profiles where any filter is applied. Similarly, if I want to just see the rule tags, I can click on that and should be able to see. So basically this DQ Asset Analytics dashboard is showing the stats of all the objects created in your profiling microservices or CDQ microservices. And this DQ dashboard is showing you the data anomalies across the enterprise. So this is what we have discussed till now, and let's jump to the next slide. So the next thing is how you can use this solution, right? So once you are done with all the prerequisite, which we have already discussed in the previous slide, you can download this package. The download link is provided in the next slide, the reference slide. And once you download this package, you will be getting three things. One Python script, one sample Power BI report, and you will be getting 5 sample CSV files. So you can simply go to your Power BI report, right? And you can open these data sets. You click on that, you click on edit query, and after clicking on edit query, you simply change the location, right, of each and every data set so that it can point it to the location where you have downloaded the sample file, right? And once you do so, you go here, click on the source, and you just update the location to where your sample CSV files are present, right? For each and every data set you do, and you just save it, and then your report should be able to show the metrics in here in Power BI. But so this is just to have a feel of how the report is looking, right? But in real time, you will be running this report on your own IICS org, right? So for that, once you download the package, the very first thing which you need to do is you need to open the Python script, and you need to update few things in the script. So the first thing which you need to update is the pod region. So this information you can get it from your IICS URL, which we have already discussed, and then you need to pass your username here, then password, IICS password you need to pass, and then you need to pass the complete path where your CSV files will be generated. Optionally, there is another variable called history record count. By default, the value is set to 10, which means your Python script is going to pull last 10 execution stats. But in case if you want to increase or decrease, you can change this value also in Python script. Once you are done, you save it, and you can execute the Python script. Once the execution is successful, you will be able to see these 5 CSV files in the location which you have specified here. So once these CSV files are generated, you open the Power BI report and you just change the path of these CSV files to the correct path where you have generated your where your CSV files are generated. And once you are done, the report will be refreshed and you should be able to see the data from your CDQ profiling results. In the next slide, we will also talk about how you can automate the profile Python script execution. So let's quickly jump here, right? So in real time, you might be interested in automating the Python script execution process, right? So if you are on a Linux machine, you can use cron schedule, right? Cron job to schedule your Python script execution. Now this is just a sample provided. So this is a sample where we are trying to schedule this Python script execution for every 1 hour, right? So like this is a sample command. It is given similar to this. You can create your cron job, right? In cron job file, you can update a similar kind of settings to automate. If you are on Windows machine, right, you can use Windows task scheduler to automate this process. The screenshot is attached. You can simply follow on how to do that. And if you are using CDI, in CDI there is a task flow called command task. In that command task, you can pass these parameters like what is shown on the screen, and you can automate the Python script execution. The only thing is your secure agent should be able to access the Python wherever you install the Python. So that should be accessible by your secure agent, and your Python script should also be accessible by your secure agent, and you should be able to automate the process of this Python script execution. In this slide, few references are provided. So all of the profiling, cloud data profiling REST APIs related information is well documented on Informatica Docs portal. So this is a link. You can refer this link, and all of the information is provided, right, related to this cloud REST API. Now, this is just a framework or a sample which we have provided. Which is pulling some data, and we have tried to build some kind of sample report on top of that. But you might be interested in exploring these APIs and build something more, right, based on your use case. And so for that purpose, you can always refer this REST API, and you can build your own solution, right? You can utilize some other APIs to extract some more information, and accordingly you can build your own reporting dashboard considering this as a base, right? And this is a GitHub link where your all the artifacts related to this solution are there. So you can download these artifacts from this link. With that, we are done with the PPT part, right? And then I can show you a demo on what changes you need to make in the Python script, how you can execute it, and once you execute it, what files will be generated, and what modification you need to make it to the Power BI report in order to see data from your IICS org for the profiling related stuff. So let me quickly jump into the Python script. So I have opened this Python script in our editor here, right? So if you see here in the first step, we are importing bunch of libraries here, which are utilized in this Python script. And that was the prerequisite. You need to have all of these libraries in place on your Python machine. And then these are the parameters which you need to update basically. So this is a pod region. Here you need to give your actual pod region, right? And then you need to pass the username, password here, and then you can give the path of the CSV file where you are trying to you will be generating all of these CSV files, and that's it. You just update these four parameters, right? And optionally, if you want to capture some more historical data, right, for further executions, you can update this parameter. And after that, these are basically the code which is checking whether the whether this particular folder exists or not. If it does not exist, then it's going to create, and if it exists, it's simply going to switch to that particular folder, right? And then we have bunch of functions written here. Like one function is to get the session ID, and then we will be using those session ID, right? And we are trying to build all of the REST APIs. Like we in previous slide we talked about, right? We are using 5 profiling APIs and 1 FRS API. So all those APIs links will be created during the runtime itself. So these are all the links which we have created here, right? The API links we have created here. And then we have for other functions, like one function is to get profiling result, and then other function is to get the FRS object details to get the additional metadata. Then there is another function to get the profiling metadata and run key. And then we have function to get the column profiling result, and then we'll be getting the top and value frequency. Then we'll be getting the profiling execution stats, right? So all of these functions are defined at the top, and then at the bottom we are calling all of these functions one by one. So if you see here, we are getting the list of the profiling, and for each profile ID we are calling the rest of the functions to generate the CSV files. And at the end, when all of the CSV files are generated, we are deleting the temporary files which we have generated as part of this process. So let me quickly update my username and password in this script, right? And then we'll execute this script to see how it is generating the CSV files. So I will pause my screen for a second to update the credentials here, and then we'll continue from there. Okay, so I have entered my credentials. I have updated my credentials in this script, right? And then to execute, I will hit this run button. So once I hit this run button, the Python script execution will start. And for each and every step, it's going to print the output message on the screen to make user aware that what exactly it is doing currently, right? So you see, it first check for the folder, and the folder does not exist, and hence it is trying to create the folder. And once the folder is created, it's trying to get the list of it has started calling the API. So the first API it is calling to get the list of the profiling, and then it's getting the metadata details, then it's getting the column profiling results, and so on. So the Python script execution will take some time depending upon the number of profiles or objects available in your profiling warehouse and FRS database, right? And the number of executions and the history you are trying to pull. Based on that, it will take some time. So we'll wait for some time for this Python script execution to complete. So script execution is completed now, and it has deleted all of the temporary files. I'll jump into the folder which I have given, right, and I'll check if all of the CSV files are generated or not. So here you can see all of these 5 CSV files are generated. Now I need to take this path from here. You can open these CSV files to see the data inside that. But what I'll do is I'll take this path from here, and I'll go to my Power BI, right? And I will update this path for each and every data set here. So I'll update this path here, and then I'll go to the next data set. Go to the source and then update the path for this also. So for all of the data set, we'll update the path one by one. Okay, so I have updated the path to point to the location where all of my CSV files are generated for all of these 5 data sets. Now, as I told, this temp underscore profile metadata details data set is created on top of profile metadata details. So this is just referencing this particular table. So we don't need to modify anything here, right? So once you are done with all the changes, and you can simply go here and click on close and apply, and it's going to apply the changes, right? And then it will, so let it apply the changes, and then see here it is loading data from the CSV files we just generated using this Python script execution. So it will load the data, right? It will refresh the data, and all of the graphs in this dashboard will automatically get refreshed with the new data. So since there was no change in the profiling data since the last time I built this dashboard reports, and that's why I did not notice any change in my graph. But once you run for your org, you should be able to see changes in your graph accordingly. You can even go here and you can click on each and every data set, and you can refresh the data, and it will refresh data in this way also. But before that, you just need to point it to correct path where your CSV files are generated. So this is how the report will look, right? And these are the sample CSV files which we will be getting as part of this particular framework. So with that said, I'm done with session for today along with the demo, and we'll open this forum for any questions you may have.
Hello everyone. If you have any queries to ask our presenters, please post them in the Q&A box. We'll try and answer them. Over to you, Vivek. Hello, Vivek. Can you hear me?
Hey, Vrinda. Can you hear me?
Please read out the questions. We can
Yeah.
read out the questions
sure.
and
So-
answer them. Can we do that?
Yep.
Yeah.
Yep. Sure. I can see now. So one question I can see, someone has asked, can we use any Informatica tool similar to IDQ Analyst instead of depending on third party? Okay, so in Informatica Analyst, you cannot create such kind of dashboard, right? In Analyst tool, it fetches data from your profiling warehouse, right? And it creates your scorecard for you. You cannot use Analyst to read some third party. You make API calls to read some other, read data from some other database and show the result there. So Informatica analyst is not for this purpose, right? IDQ analyst is basically when you are trying to do profiling in IDQ and show the result in analyst in a scorecard or profiling. But certainly you might be interested in utilizing some third-party reporting tool to build some kind of dashboards. And even someone asked earlier that can we have this as a standard solution? So yes. We are going to in our roadmap we have scorecard right on CDQ also. So scorecard is there and it is planned for early this year. So that will be there. But again, the scorecard will be similar to how it looks on IDQ, right? So it will be, you will be able to combine multiple profiles to show data in a particular scorecard. But in case if you want to have certain kind of holistic view, right, enterprise-wide view, in that case you might be interested in building such kind of report. So in short, IDQ analyst tool, you cannot use it to build such kind of intuitive dashboards, right? Then one question I can see: have you looked into the new scorecard metadata yet, such as threshold? I did not get that question exactly. So scorecard will be there as part of we have on roadmap, right? So that will be available in CDQ. Same kind of features what we have currently in IDQ. So you will be able to combine multiple profiles, and then you will be able to define your threshold scores, and there you will be able to see those trend charts based on your threshold score, what is acceptable, what is not acceptable, those kind of things. But in case if you want to utilize this solution, again, this is just a framework, right? You can always read your profiling warehouse data, and you can build, you can define your own threshold wherever you're trying to call this profiling data, right? Either in Python script, or maybe you can use CDI or CAI. So there you can design your own threshold, right? And you can do this stuff there.
Thank you, Vivek. I think we have one more question.
Yeah, I can see one more. Will there be more versions of Power BI data quality dashboard developed? So this is just a framework, right? It's not a full-fledged solution. So it's just a framework. In case if you want to do, again, when I say framework, it's just a sample, right? There are, you can do a lot of things using these APIs. So you can utilize, you can just treat it as a base, right? Base product, and you can build your own use cases utilizing this. So will there be any other version? So no, this is just a framework, right? You can, based on your own use cases, you can try to build what exactly you're trying to achieve, right? So just consider this just as a framework, not as a solution, and modify it based on your need. Also,
Thank you,
a few
Vivek.
questions. Yeah, Vrind, a few questions we have already answered in chat, but I can take one from there. Maybe it will be useful for bigger audience here. So someone asked, can we use Power BI directly to IICS instead of using some third party, Python or something else to call the APIs? So yes, Power BI does support API calls, but if you notice in our Python script, we are calling multiple APIs, and it's a kind of nested API call, right? From one API, we are getting the list of profile, and that we are getting that profiling ID, and then we are passing it to second API, and then we are getting something from the second API, then we are passing that result to third API, and likewise, right? That kind of complex call, you cannot make it in Power BI directly. That's the reason we are utilizing Python here to make all those calls and pass the data in relational format. Of course, if you don't want to use Python or any language, right, you can utilize any language which is capable of calling APIs. If you don't want to do that, and you can always go with CDI or CAI if you are aware about those processes, right? How to call those APIs in CAI or CDI and parse it in relational format. You can always utilize those.
Thank you, Vivek. Everyone, if you have any queries to ask our presenter, please post them here in the Q&A box. We'll try and answer them. Also, the session is being recorded, and it will be available in the Informatica Support YouTube channel and the Success portal. You'll also be able to download the slide deck from the Success portal. Also, end of this webinar, we have a post-webinar survey. Please put in your feedbacks and suggestions there. We'll love to get to know from you how you like this session, and if you have any future suggestions for the webinars, let us know through that. Vivek, would you like to call out any questions that we have previously answered?
Yeah, Vrinda. So let me quickly go from the start, and maybe it will take just few minutes, right? Maybe it will be useful for bigger audience. So why we use Python to call API, that we have already discussed, right? It's just a framework, right? And we have used Python because uh, 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 if someone is having expertise to do it in CDI and CI, that's the best way to do it, right? You can simply you build processes, right, in CI or in even in CDI, and you can call. If you can do it, that's you can always utilize that, right? But this is just a framework where we have utilized an open source tool, Python, to do so. And many people, we have seen many customers who look for such kind of solution. That's the reason we have used Python here. Again, using CDI and CI, there is already a value accelerator kind of thing provided on Informatica portal, which is basically using CAI to call these APIs, and there we have a custom data model. It's not like this. So in here we are trying to generate simple CSV files, and on top of those CSV files we are trying to build a report. But on Informatica portal there is a value accelerator which is calling CI, which is using CI to call these APIs, and it is dumping the data into a separate data model altogether. So if someone is interested, they can leverage that option also. Can we call API directly with CI? That we have already talked about. Can't we connect PowerBI directly to IICS? That also we have already talked about. A roadmap, yes, we already have a scorecard in roadmap, which will be early this year, which will be similar to what IDQ is doing currently, right? Basically showing the trending chart with the multiple profiles, the way you configure it. So based on the threshold you define it. So it will be similar to IDQ. Are these Python scripts uploaded to Git? So yes, in the PPT itself, the link is provided. So after this session, once the PPT this doc is available, you can always go and check from there. Then one question I can see is there any document which provides the data model view of a repository database to know the name of column or table which can provide useful information? So the FRS or profiling warehouse will not be available directly to any user because it's Informatica managed, right? You can query profiling warehouse and FRS database using the REST APIs, and a very well documentation is provided on Informatica documentation portal regarding this APIs. So that link is also shared in the document which we presented today, and it is talking about all the possible APIs which profiling warehouse is having, right? So that you can always refer, and that it talks about all the possible APIs and from which API what exactly you can get. Along with samples also it is provided there, so you can refer that. I think we have covered everything, Vrinda, all the questions from the previous.
Yeah, looks like we have covered most of the questions, and already we are on top of the hour. Thank you, Vivek, for this wonderful session. Thank you, Rakesh, for joining as a panelist. I hope you enjoyed the webinar, everyone. We'll be coming up with a new webinar in the next Tuesday as well. Please stay tuned. Also, if we have failed to answer any of your questions here in the Q&A box, we'll get back to you right after the session. Thanks, everyone, for joining. Bye. See you on our next Tech Tuesdays. Bye.